بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. I would like to welcome my students from grade 12 into the third online lesson regarding probabilities. So in the previous two lessons, we've talked about some of the fundamental theorems of probabilities, and we have also discussed the construction of the probability model. Now in this lesson, this is the third lesson, we'll discuss two different topics. One of them is going to be about the conditional probability, and the second one is going to be about the topic of independent events. Now the lesson objectives are the following. By the end of this lesson, you should be able to recognize and solve problems with conditional probabilities, recognize and solve problems with independent probabilities. Now, this lesson is going to be divided into two parts. One part is going to be for conditional probabilities, and the other one is going to be for independent probabilities. And we will start with the first part, which is conditional probability. Now, to understand this part better, we're going to look at this example. So let's read this example together. Given the sample space S contains the number from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A number is chosen at random. So we chose a number at random. What is the probability that the chosen number is A, even, B, multiple of 3, C, multiple of 3 and even, D, given that the chosen number is even, what is the probability it's a multiple of 3, E, given that the chosen number is a multiple of 3, what's the probability it is even? Okay, so let's investigate this question together and see what techniques do we follow in order to solve such problems. Now, the sample space we have is from 1 to 10. In part A, they are actually defining an event for us. So we have an event. Let's call this event event A. What is this event exactly? It's the event of getting an even number. We're going to choose a number, right? So this event is the event of getting an even number. Now, before we calculate the probability of getting an even number, it's always good to list the possible outcomes with which you can get an even number. Now you're going to choose a number from this list. What numbers can you choose and they are even? You can choose 2 or 4 or 6 or 8 or 10, right? So the probability of getting an even number is the probability of A, which is going to be the number of elements in A over the number of elements in the sample space. This is the formula that we have discussed before. And the number of elements in A is 5 elements. Just count them in front of you. And the number of the elements in the sample space is going to be 10. And 5 over 10 is simply 1 over 2. So we can say that there is half chance or 50% a chance of getting an even number when you choose a number at random. So you just put the numbers in front of you, close your eyes, put your finger somewhere on one of the numbers. Now there is a 50% chance that the number that you have put your finger on is an even number. Okay? Let's check the second part. Now the second part, B, is actually asking about another event. So in part B, we have another event. We can name it B, for example. So this event is the event of getting a multiple of 3. Getting a multiple of 3. Okay, now look at this, guys. Now we have a set in front of us. It is from 1 to 10. What numbers apply this probability, which is getting a multiple of 3? So which numbers can we say are multiples of 3? Now if you look at the set carefully, you will notice that the multiples of 3 are either 3 itself or 6, or 9. So what is the probability of getting a number that is multiple of 3? It's the number of elements inside of B over the number of elements inside of S, and that is 3 over 10, which cannot be reduced more. So you can say it's roughly 30%. So there is a chance of 30%. It's actually exactly 30%. So there is a chance of 30% if you put your finger on one of the numbers from 1 to 10, closing your eyes at random, there is a chance of 30% that the number that you have chosen is a multiple of 3. Okay? So let's imagine this together. We have 10 cards from 1 to 10, and you're closing your eyes and you're trying to choose one of these cards. So you put your hand on one of these cards. So there is a 30% chance that the number that you have put your hand on is a multiple of 3. There is a 50% chance that the number that you have put your hand on is an even number. Okay? The third one, C. Now in part C, now this is where the thinking starts. In part C, event C actually is not a unique event. Why? Because in event C, we want to get a multiple of 3 and even. Now, the first event, which is the event of getting a multiple of 3, this event here, the event of getting a multiple of 3, is actually defined as B. We have defined this as B. The second event, which is the event of getting an even number, was defined as A. The word and, we talked about the word and in the previous class, and we said it is usually translated as intersection. So in part C, what they're actually looking for, they're looking for B intersection A, right? So they're looking for, so we can simply say that here they're looking for B intersection A, or BA, right? Okay, now before we start with finding the probability of BA, before we find the probability, we should find AB or BA itself. How do we find it? We just look for the common between A and B. So what's the common between this set and this set? We will notice that there is only one number which is common, and that number is 6. So we can simply say that the probability of BA or AB doesn't matter. The probability of AB is the number of elements in the sets, the elements in the set AB over the number of the elements in the set S. So this is going to be 1, because we have one element only, over 10. So there is a 10% chance that the number that you have chosen is both a multiple of 3 and even. So here, the intersection here actually means that both events happen together. So the intersection means that here, it means that both events happen together. Okay? Now part D is a little bit different. Now please pay attention to the following, because this is going to be the introduction to our lesson. Now, in part D, he says, given that the chosen number is even. So now, okay, so now we know that the chosen number is one of these numbers. That's it. It has been decided that the number that we have chosen is even. So you've chosen a number, you're still closing your eyes, you've chosen a number, okay? So you heard someone telling you that the number that you have chosen is even. Okay, so now you know that you have chosen either a 2, or a 4, or a 6, or an 8, or a 10. What is the probability that the number that you have chosen is a multiple of 3? Please pay attention to the following. Now again, let's imagine the whole situation together. So we had 10 cards, right? And I told you to put your hand on one of the cards. You closed your eyes and you put your hand on one of the cards. Now you heard my voice telling you that your hand is on an even number. I asked you not to open your eyes. I told you that your hand is on an even number. Now, what is the probability that you have put your hand on a multiple of 3 as well? Okay? So to know this, we have to investigate inside of this set we have to look for the multiples of 3. So inside of this set, what are the multiples of 3? The multiples of 3 is actually only 6, right? This is the only number which we can say is a multiple of 3. By the way, we got this number before when we found AB, because this number was both even and a multiple of 3. So what is the probability of, look at this guys, of getting a multiple of 3? Remember, this is event B, of getting a multiple of 3, given that, this sign means given that we have chosen an even number. What is the probability of getting a number that is a multiple of 3, given that we have chosen an even number? Okay, so the probability is 1, because there is only one multiple of 3, which is 6 in that set. In this set here, there is only one multiple of 3, which is the 6, over 5. Now, why is this 5? Because we simply have 5 even numbers. Now, look at this, guys. When I told you that the number that you have chosen is even, then this means now that your sample space is no longer from 1 to 10. No, your sample space is only the even numbers from 1 to 10. Your sample space has changed. Your sample space has become A itself. So now A has become your sample space. Because I've told you, remember that your eyes are closed. I told you that you have put your hand on an even number. So now in your head, you don't think of the numbers from 1 to 10 anymore. No, you have chosen an even number. So your sample space is either a 2 or a 4 or a 6 or an 8 or a 10. So your sample space now is only 5 numbers, and there is only one multiple of 3 out of these 5 numbers. So it's going to be 1 over 5. Let's do the second one. Maybe the picture is going to get clearer. Now look at this. Part E. They say, given that the number that you have chosen is a multiple of 3, what is the probability that it is even? Okay, now look at this, guys. Again, you have the cards from 1 to 10. Your eyes are closed. I told you to put your hand on a number. So you've put your hand on a number. Now your eyes are still closed. I told you that your hand is now on a number that is a multiple of 3. So where do you think your hand is? On which card? Now you think that your hand is on either a 3 or a 6 or a 9. So now your sample space is not all the numbers from 1 to 10. No, your sample space is simply now B, right? And now what is the probability that your hand is on an even number? By looking at B and looking for any even numbers, we will notice that there is only one even number, which is 6, which is AB, right? 6. So this means that the probability that your hand is on an even number, given that you have already chosen a multiple of 3, is going to be one number out of 3 numbers. Okay? These last two probabilities right here, both of them are called conditional probabilities. Now, I want you to notice something. In the probability of B with condition of A, we have calculated this probability by calculating the number of the elements in AB, right, which is one number, over the number of elements in A, which were 5 numbers. So we got 1 over 5. And this can also be written as the following. It can be written as the probability of AB over the probability of A. Notice that the denominator now is not the number of S, it's the number of A. Why? Because this is the new sample space. We can think of it like this. It's a new sample space. When we did the opposite, when we were thinking of the probability of A given B, or with condition of B, we solved it as the number of elements in AB as well, which was 1. Look here, it is 1. But this time we divided by the number of elements in B. Or we can say it's the probability of AB divided by the probability of B. You will see now that these two rules really check, they're the same thing. So now our new sample space has become the probability of B. So actually, you can say the following. You can say that the second letter becomes your new sample space. So it becomes the denominator. In the numerator, you put the intersection. In the denominator, you put the second number. And this is how you calculate the conditional probability of any two events. So to calculate the conditional probability, if you want to calculate the probability of A with condition to B, then what you should do is you divide the probability of AB divided by the probability of B. Now notice that the second letter here is B and the letter in the denominator is B. If it's the opposite, if you want to calculate the probability of B with condition to A, then it's going to be also the probability of AB, but this time divided by the probability of A. Notice that the second letter always becomes the denominator as your new sample space. Now let's see how do we apply this on some questions, and we will start with the first example. Okay, so the first example says the following. Here, given that the probability of A is 0.2, the probability of B is 0.3, the probability of A union B is 0.4, find the following. The first thing they want us to find is the probability of A given B dash. Okay, look at this, guys. I want to draw your attention to something. All of these questions that we're going to discuss today are going to be ministry questions, and the method is really quite straightforward. Let's see. Okay, so the first thing they want us to do here is they want us to find the probability of A condition B dash. Okay, so we've just learned that the probability of A condition B equals the probability of A, B, right, divided by the probability of the second letter, which is here B. Good? So this is what we have learned as conditional probability. They don't want A, B, they want A, B dash. So if this is B dash, this is going to be also B dash, and this is going to be B dash. Good? So this is the beginning. Here, now on the side here, do we have the probability of A, B dash? We will notice that we don't have this. And the same thing, we don't have the probability of B dash. So we will try to find them using the formulas that we have learned in the previous lesson, the theories and the axioms of probability. So I'm going to start with the probability of A, B dash. Now we had a rule for this the last time. We said it was the probability of the one without the dash minus the probability of both of them, A, B. Good? So we want to find the probability of AB dash. Do we have the probability of A? Yes, we actually have it, 0.2. Do we have the probability of AB? We don't have this. But in the previous lesson as well, we've learned that there is a relation between the probability of A union B and the probability of AB. We've learned that. So let's call this now, let's call this here 1, line 1. Let's call this line 2, okay? Now, we know this formula. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of AB, right? Now we know this formula. The probability of A union B is given to me. It is 0.4. The probability of A is also given to me. It is 0.2 plus the probability of B is 0.3. So the only thing missing is the probability of AB. Good? So to find it, since it's negative, I am going to transpose it to the other side to make it positive. And I will move 0.4 to this side. So this is negative probability of AB. I will move it to the other side. It becomes positive probability of AB. So its probability of AB equals 0.2 plus 0.3 is 0.5 minus, and then you will transpose the 0.4 to the other side, so it has become negative. 0.5 minus 0.4 is 0.1. So the probability of AB is 0.1. Good? Now what are we going to do with it? We are going to substitute this. We're going to substitute it in line 2. So we're going to substitute this again in line number 2. So let's see what's happened. So when we substitute this in line 2, we will notice the following. We can notice now that we can notice that the probability of AB dash here, the probability of AB dash is equal to the probability of A. Notice this is line number 2. Here, this is line number 2. The probability of A, which is 0.2, right? So the probability of A is 0.2 minus the probability of AB, which is 0.1. So 0.2 minus 0.1, we get 0.1. So this is the probability of AB dash, and now we got the numerator. What about the denominator? Well, the denominator is easy as well, because we have a formula for the denominator, right? We have a theory for the denominator as well. We know from the previous class that the probability of B complement is equal to 1 minus the probability of B. So this means it is 1 minus the probability of B is 0.3. This one, you think of it as 1.0, so it's 10. 10 minus 3 is equal to 0.7. So the probability of B dash is 0.7. So now we can solve this. So now we're going to substitute in line number 1. So we get the following. We get that the probability of A with condition of B dash is equal to the probability of AB dash, which is 0.1, over the probability of B dash, which is 0.7. We can actually cancel the 0 point with the 0 point because we have 1 decimal place, 1 decimal place. So we will get 1 over 7. So the probability of AB dash is equal to 1 over 7. And what was important in this here, what we have found is actually the following. We have found the probability of AB, we have found the probability of AB as, let's choose a yellow highlighter. Okay, we've found the probability of AB as 0.1. We found the probability of AB dash as 0.1. We found the probability of B dash as 0.7, and we have found the probability of A, B dash with condition of B dash as 1 over 7. Okay, so this was part A of the question. Let's check the second part. So the second part wanted the probability of A dash union B. Okay, so part B, they wanted the probability of A dash union B. Now we know this formula. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of AB, right? We know this formula. But this time they don't want A union B, they want A dash. So I'm going to change every A into A dash. So this becomes A dash, then this becomes A dash. Okay? So, do we have the probability of A dash? We do have this one. We don't have this one, and this one also we don't have. The probability of A dash B. Just to remind you, what we have found in the previous question was the probability of AB dash. This time they want A dash B. So, the first thing that you will do is to find the probability of A dash, which is going to be 1 minus the probability of A. So it's going to be 1 minus the probability of A is 0.2. So this one is 1.0, minus 10 minus 0.2 is 0.8. So we have found the probability of A dash, we have found this one. The second thing is the probability of A dash B. So to find it, we will follow this formula that we have also taken in the previous class. So this is going to be the probability of the one without the dash minus the probability of both of them without dashes, right? Remember this? So the probability of B is going to be 0.3 minus the probability of AB was found in the previous slide. So the probability of AB is right here. It is 0.1, so we can use it now here, 0.1. So this becomes 0.2. Okay? So now we will substitute in this line. So probability of A dash union B is equal to the probability of A dash, which is 0.8, plus the probability of B, which is 0.3, minus the probability of A dash B, which is 0.2. And now we will add 0.8 plus 0.3, we'll get 1.1, minus 0.2, we'll get 0.9. So the answer is going to be 0.9. And this is going to be the answer to the second part. Of course, you can get these questions. It's highly likely that you can get these questions. It's possible to get these questions as multiple choice questions. They can give you the question and they will just give you these numbers at the answers. And you must choose the correct number. Okay? So you must solve the question in order to find the correct answer. Let's do another question. So a second exercise. Given that the probability of A is 2 over 5, the probability of B is 3 over 10, and the probability of A union B is half, find the probability of AB. Okay? So this should be quite easy. First of all, to find the probability of AB, remember that we have a relationship between AB and A union B, right? So we know this formula. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of AB. Okay, now the probability of A union B we have, it is half. The probability of A is also given, it is 2 over 5. Plus the probability of B is 3 over 10, so all of these are given, and the probability of AB is required. Since it's negative, I will transpose it to this side, and I'll transpose the half to this side. So I will get that the probability of AB is equal to add these two fractions, I'll actually multiply this by 2 here and multiply this by 2. So the denominator would become 10. And the numerator would become 4 plus 3. Then I don't forget to minus 1 over 2. Now I will notice that these denominators are also different. So I'm going to unify the denominators by multiplying here by 5 and multiplying here by 5. So the probability of AB is going to be equal to 7, the denominator is 10, here is 7, 4 plus 3, minus 5. So the answer would be 2 over 10, which is after cancelling 1 over 5. So the probability of AB is 1 over 5. Let's check the second part. So the second part says that we want to find the probability of A with condition to B. Okay, so this part should be easy now. So part B, we want the probability of A with condition to B. So this is going to be the probability of AB, both of them, over the probability of the second letter, so the probability of B, right? So the probability of AB is what we have just found in part A. You see the probability of AB is actually here. So the probability of AB was equal to 1 over 5. So we're going to use that now in the second part. So this is 1 over 5 here. This is 1 over 5 over the probability of B is 3 over 10. And as usual, we don't like fractions over fractions, so we're going to keep, change, flip. So this is going to be 1 over 5 multiplied by 10 over 3, and we can cancel the 5 with the 10, we will get 2. So this becomes 2 over 3 eventually, which is more than 0 and less than 1, which makes sense, okay? Because we said that probabilities should always be between 0 and 1. Okay, so let's look at the third example now, the third exercise. And the third exercise says the following. If the probability of A union B is equal to 0.4, the probability of A dash with condition to B is 0.5. The probability of AB dash is equal to 0.2. Find the probability of BA dash. Now, I'll be honest with you guys. It was quite risky of me to put this example in the slides. I always think of this question as one of the hardest questions that ever brought in the ministry. But, and I always like to discuss it with my students face to face just to see how they can get into different clues in solving this question. And over the years, plenty of students solve this question in different ways. I'm going to show you now one of the easiest ways I think this question can be solved with. Now, I think you might notice the problem that we have here. You see, what we want, part A, what we want is the probability of B with condition to A, BA dash, which is, according to the theorem that we studied in the previous class, is equal to the probability of the one without the dash minus the probability of both of them, AB. Now, the problem we have is that we don't have the probability of B. We don't have the probability of AB. So how are we going to get these? So let's start from what's given. So what's given, first of all, is the probability of A union B. Okay, this is a theorem. It's a rule, it's a theorem that we have studied in the previous class, which is equal to the probability of A plus the probability of B minus the probability of AB. But you might notice that all of these guys, probability of A, probability of B, and probability of AB, they're all unknowns. The only thing we know in this theorem now, in this line, the only thing we know is the probability of A union B. We know that this is 0.4 equals to the probability of A plus the probability of B minus the probability of AB. So how many unknowns do we have here? We actually have 3 unknowns. And whenever you have 3 unknowns, you must have 3 equations. So if this was the first equation, let's call this equation 1. So let's investigate together what is the second equation. Well, the second equation can be acquired from here. The probability of A dash with condition to B. We know that the probability of A with condition to B is equal to the probability of AB, right, divided by the probability of the second, which is the probability of B. Now, in this question, I have A dash So this means that this is A dash B over the probability of B. Again, in this line, the only thing we know is the probability of A dash B, and the probability of A dash B is actually 0.5. So this is 0.5 equals the probability of A dash B, which we don't know, over the probability of B. Okay? And again, we don't know these two. Okay. What can we do here? The one in the numerator, you see the one in the numerator, which is the probability of A dash B, this is equal to a rule that we have studied in the previous class. So we can say that 0.5, right? Sorry. So we can say that 0.5, which is here, okay, so 0.5 equals, this is the probability of the one without the dash, which is B, minus the probability of both of them, AB, over, all over the probability of B. Now, don't you dare cancel this with this. This is not possible at all. Why? Because there is a subtraction between them. What we can do is the following, however. Look at this, guys. If you have A minus B over C, you can actually split the denominator for both terms in the numerator. You can do something like this. You can split the C for the numerator. Whenever there is a minus or a plus in the numerator, you can do this. So if there is a minus here, or maybe if there is a plus, it's the same thing. So I will do the same thing here. So what I'm going to do is writing the following. All right, that 0.5 is equal to the probability of B over the probability of B minus the probability of AB over the probability of B. Okay? What are we going to get out of this? We can cancel now these two. So we will get the following. So we will get that 0.5 is equal to 1, because we cancelled something with itself, minus the probability of AB over the probability of B. We can then do the following. Since this fraction is negative, I will move it to this side, and I will move 0.5 to this side. So I will get that the probability of AB over the probability of B is equal to 1 minus 0.5. So this one is actually 1.0, it's 10, 10 minus 0.5, you get 0.5. So the probability of AB is equal to, or over the probability of B is equal to 0.5. And we can think of this as equation 2. Okay? Now, again, we said that we need 3 equations because I have 3 unknowns. The third equation can be found from here. So maybe this is a little bit messy, but I hope that you're following with me. So the third equation, so this is the first equation right here. This is the second equation right here. And the third equation, I'll do it just right here. So we have the probability of AB dash. And we know that this is going to be equal to the probability of A minus the one without the dash minus the probability of both of them without dashes, right? So AB. Now, from here, everything will be solved now. Look, probability of AB dash is equal to 0.2. Do we have the probability of A? Of course, not yet. Do we have the probability of AB? Of course, also not yet. Now we will call this equation 3. Okay, now guys, let's look carefully at equation number 1. Okay? This is the probability of A minus the probability of AB, which is the same as this, probability of A minus the probability of AB. So what I can do now is, since I know that the probability of A minus the probability of AB is 0.2, I can replace both of these terms by 0.2. How is that? Look, so I can say the following. I can say, therefore, in equation 1, I can say that 0.4 is equal to, I will replace both of these guys by 0.2 because the probability of A minus the probability of AB is 0.2. And I will be left also with the probability of B. Good. This is only one unknown. I can transpose this easily here. So 0.4 minus 0.2 equals the probability of B. And therefore, the probability of B is equal to 0.2. So now we have found ourselves the first one of the unknowns. The probability of B is 0.2. Let's highlight this. So I'm going to highlight it with a different color. So this is the probability of B. Okay? Now where do we take this? We will take it to equation 2. Do you see where equation 2 is? Equation 2 is right here. Yes. So we're going to come to equation 2 now. So here, substituting the probability of B equals 0.2, we will notice that the probability of AB over the probability of B is equal to 0.5. Look at this equation, 0.5. I'm going to substitute the probability of B by 0.2. So let's just erase it and write instead of it, I'll erase it and write instead of it the probability of B itself, which is 0.2. So here I'm going to write 0.2. Okay? So how do we find the probability of AB? I'm going to cross multiply. So by cross multiplying, don't know where to finish now. Sorry guys, so I'm going to finish here. Don't have a whiteboard anymore. So the probability of AB is equal to 0.2 multiplied by 0.5. Okay, I know that some of you might have forgotten how to multiply decimals with each other. So I'll just remind you with that. So if you have 0.2 multiplied by 0.5, what you do is you ignore the decimals, you just multiply 2 by 5, you will get 10, right? And then you will count how many decimal places here, you have 1 decimal place. How many decimal places here, you have 1 decimal place. You will add the number of the decimal places, so you'll have 2 decimal places. So in the answer, you will count 2 decimal places and put the point. So the answer is going to be 0.10. So 0.10 and 0.1 is the same thing. The zeros to the right of the decimal are not important, so it's 0.1. So the probability of AB is equal to 0.1. We have found ourselves now the second unknown. So let's use a highlighter here as well. And actually, guys, I don't need to find the third unknown. Do you know why? Look, what I want to find is the probability of BA dash. This is the probability of B minus the probability of AB. I have found the probability of B and I have found the probability of AB, so I can find now this. If I want to find the third unknown, I'm going to use this equation. I have the probability of B, I have the probability of AB, I have the probability of A union B, I can find the probability of A. I don't know if I need that, but since, if I need that for part B, I know, but since I don't need it now for part A, I am going to finish part A with what I have. So therefore, the probability of B A dash is equal to the probability of B, which is 0.2, minus the probability of AB, which is 0.1. So here it is, this one is 0.1. So 0.2 minus 0.1, how much is the answer? the answer is going to be 0.1. So this is the probability of B A dash. Again, if this question is a bit hard, please try to repeat it more than once. I know that this is one of the hardest questions in the ministry because it has a lot of work and we have a lot of unknowns, but I trust that this is the easiest way you can solve it. There is another way another way that students can solve with, which is using drawing, but this way cannot be easily explained on slides here. So that's why I'm just going to stick to this way. In the question, there was a second required. They asked for the probability of A union B. So let's see. The probability of A union B was, I think it was A dash union B. Let me make sure of the question. I have it somewhere here. I think it was the probability of A dash. Yes, it's the probability of A dash union B. A union B dash. Actually, this was A union B dash. Let me change the question a little bit. So this A union B dash. Okay. So this was the second part that they required in the question. Let's see now. So part B, they wanted the probability of A union B dash. Okay, so we know A union B is the probability of A plus the probability of B minus the probability of AB. But this is not B, this is B dash. And this is not AB, this is AB dash. So this can be the following. It can be the probability of A plus, we don't have the probability of B dash, but it's 1 minus the probability of B, right? Minus, we don't have the probability of AB dash, but it's probability of the one without the dash minus probability of both of them. Good. Notice that I have put these in brackets because I have a minus before it. This minus applies to both of them. So this is going to be the probability of A plus 1 minus the probability of B minus the probability of A plus the probability of AB. Now look at this, guys. I still do not have to find the probability of A because they will cancel each other. So I'll have 1 minus. I have found the probability of B from the previous part. Probability of B was here. It's 0.2. So 1 minus 0.2 plus the probability of AB also was found in the previous part. Probability of AB was 0.1. So plus 0.1. So this one is actually 1.0, it's 10. 10 minus 2 is 8. 8 plus 1 is 9. So this is simply 0.9. So this is the probability of A union B dash. Okay, I hope this part is clear. And with this exercise, actually, we're going to be done with the first part, which is the part of the conditional probability. Now the second part is going to be the part of the independent events. And we will explain this part now, and we will see its relationship to the previous part, which is the part of the conditional probability. Okay. So in the second part, which is the part of the independent events, we will discuss now the meaning of the independent events through an example. So let's look at this example. The example says the following. A die is thrown once. What is the probability that the apparent number on the top is event A, 4, event B, even, event C, less than 3. And then the second part, calculate the probability of A, condition B, B, condition C, and C given B. Okay, so let's solve this question together, and through this question we will discover together the meaning of the independent events. Okay, so a die is thrown once. Let's write the sample space. So the sample space is going to be the following. It's going to be the numbers 1, 2, 3, 4, 5, 6, since we are talking about the die, right? So what is the probability that the apparent number on top is event A? So event A has only one number, which is 4. So what is the probability of A? The probability of A should be the number of elements inside of A over the number of elements inside of S, and this is going to be one number over 6 numbers. So it's 1 over 6. As simple as that. Let's do the second part, B. So in part B, we're looking for even numbers. So even numbers from the sample space are 2 and 4 and 6. And the probability of B is actually the number of elements inside of B over the number of elements in the sample space, which is going to be 3 elements out of 6. And after cancelling, we will get 1 over 2. In part C, event C was a number less than 3. So numbers less than 3 from the sample space are 1 and 2. The probability of C is equal to the number of the elements inside of C over the number of elements inside of S, which is going to be 2 out of 6 after cancelling, which is 1 over 3. So the first part is quite straightforward, nothing hard there. The second part, so this is part 1. The second part, part 2, they want us to calculate the probability of A with condition that B happens. Okay, so we know from the first part of this lesson that this is going to be the probability of AB over the probability of the second letter, which is B. The probability of AB means the probability of the common between A and B. So let's do it here. So AB is equal to the common between A and B. Look, this is set A, guys, here. This is set A, and this is set B, right? Right here. So what is common between them? What's common between them is 4. So the probability of AB is equal to the number of the elements in AB over the number of the elements in S, which is going to be 1 element out of 6 elements. So this is here, this is 1 over 6 divided by, the probability of B is already found, it's 1 over 2. So what are we going to do now? We will multiply, we will keep the first, change the division, and flip this. So keep, change, flip, we will get, we can cancel the 2 with the 6. We get here 1, and we get here 3, so we will get 1 over 3. So this is the probability of A with condition to B. So notice that the probability of A was 1 over 6 originally. So originally, the probability of A was equal to what? To 1 over 6. This was the probability of getting a number that is 4. But when we knew that our number is even, the probability of A given B, the probability has changed into 1 over 3. Guys, by the way, this is the probability of A, and this is also the probability of A. But this is the probability of A given that we have already chosen an even number. The same with the card analogy. This time we have 6 cards. So if I ask you to close your eyes and put your hand on a card, then the probability that this card is 4 is 1 over 6. But if you hear me telling you that your hand is on an even number, then in this case, the probability that this number is 4 is 1 over 3. So the probability has changed, right? We call such events dependent. So they depend on each other. So A depends on B. The value of the probability of A changes depending on B. But does this happen all the time? Let's investigate the second one, which is the probability of B given C. So this should be the probability of BC over the probability of the second one, which is C. Okay, here, let's find BC. So how much is BC? What is common between B, underlined already, and C? So what is common between them? You notice that what's common between them is 2. So what is the probability of BC? The probability of BC is the number of BC, of elements inside of BC, over the number of elements inside of S, which is 1 over 6. Good? So the probability of BC is 1 over 6. Okay, let's write it. Over. The probability of C is 1 over 3. It's right here, 1 over 3. Now, I'm going to keep change and flip. So this is going to be 1 over 6 multiplied by 3 over 2. If I cancel, 3 over 1, I'm sorry. If I cancel the 6 with the 3, so I'll get here 1, I'll get here 2. So this is 1 over 2. So has the probability changed? Yes. No, it has not. Look, the probability of B normally is half. The probability of B with condition to C is still half. Nothing has changed. It's still the same probability. So this means that the probability of B with condition to C is equal to the probability of B. It's not going to change. If we're talking about the probability of B alone, it's half. If we say it's the probability of B with condition to C, it's still half. What does this mean in words? Okay, so we have 6 numbers. Okay? Now you close your eyes. Now you're going to put your hand on one of these numbers. What is the probability that your hand is on an even card? The probability is 3 over 6, which is half. So 50% chance that now your hand is on an even card. Okay, what if I tell you, be aware, the card that your hand is on is less than 2. So it's less than 3, I'm sorry, it's less than 3. So now, of course, you're going to eliminate the 3 and the 4 and the 5 and the 6 cards from your head. So what cards do you think that your hand is on? It's either 1 and 2. So what is the probability that your hand is on an even number? It's still half. It's still 1 over 2. So the probability has not changed. In this case, we say that B and C are independent events, or we say that B is independent of C. Independent of C. It doesn't matter. It doesn't matter what the value of C is. B is going to stay the same. It's going to be half. Okay, if B is independent of C, does that mean that C is independent of B as well? Oh, well, to know that, we'll have to check it out. Let's check it out in this corner. So let's do the third part. So the third part, they wanted us to find the probability of C condition to B. So this is the probability of BC or CB, it's the same thing, guys, over the probability of the second one, which is B. The probability of BC we have already found. The probability of BC, it's 1 over 6, it's right here. So it is 1 over 6 over the probability of B is 1 over 2. So what are we going to do now? We'll keep, change, flip. We'll cancel the 6 with the 2. We will get here 1. We'll get here 3. So the answer would be 1 over 3. Now notice that this answer is the same as the probability of C itself. So this means the probability of C given B is the same as the probability of C. It's not different. And this means that if B is independent of C, then the opposite is also true. So if B is independent of C, so therefore we can also say, therefore C is independent of B. So what do we mean by independent events? Independent events is an event whose probability is not going to change. The probability of the event is not going to change if we make it with condition to another event. So the probability stays the same. Notice that A and B here at the beginning, A and B, these are not independent. These are actually dependent. A depends on B, and if you do the opposite, you'll notice that they depend on each other as well. So A depends on B and B depends on A. They're dependent on each other because the probability changes. But B and C are independent because the probability does not change. Whether you make it with condition or without condition, it's still the same probability. Okay? So this is the meaning of the independent events. Now, when two events are independent, there is something important that I want you to notice. Look, so if A and B are independent, then what does that mean? It means that the probability of A with condition to B will be the same as the probability of A. So the probability of A with condition to B will not change. And the probability of B with condition to A will be the same as the probability of B, right? This is what we have just discussed in the previous slide. Okay, look at this, guys. The probability of A with condition to B is actually, it has a rule. It's the probability of AB over the probability of B equals the probability of A, right? What happens if we cross multiply? Well, if you cross multiply, the same thing here, by the way, the probability of AB over the probability of A equals the probability of B. If you cross multiply whether here or here, both of them, you will get the following. You will get that the probability of AB is equal to probability of A times the probability of B. Now this here is an important law. Sorry, I should have used okay. This here is an important law, and we use this law only when two events are independent. So if A and B are independent, they're independent events, then we can simply say that the probability of AB is equal to the probability of A times the probability of B. So this multiplication happens only if the events are independent. This kind of reminds us with the mutually exclusive events. Probability of A union B equals probability of A plus probability of B. We said that we can use that rule only if the events are mutually exclusive. This time, we can use this rule only if the events are independent. And they will tell you in the question whether they are independent or not. And by the way, guys, if A and B are independent, then A and B dash are also independent. So the probability of A B dash is equal to probability of A times probability of B dash. The same thing with A dash and B. The probability of A dash B is the probability of A dash times the probability of B. The same thing with A dash B dash. The probability of A dash B dash will be equal to the probability of A dash times the probability of B dash. I think this is going to be a lot clearer with some examples, so let's look at some examples. And again, all of these examples are actually ministry questions, so you'll find them in the ministry questions section of your book. So, given that A and B are independent, so look at this, guys. In the question, they're stating that A and B are independent, so they're telling us so. The probability of A is 0.4, the probability of B is 0.3, find the probability of A union B. Okay. So the probability of A union B, we know from the theorems that we have studied in the previous class, is equal to the probability of A plus the probability of B minus the probability of AB. Okay? The probability of A is given. I have it, 0.4. The probability of B is given. I have it, 0.3. The probability of AB is unknown. However, because A and B are independent, and that is given in the question. So we can simply say that the probability of AB is equal to the probability of A times the probability of B. So here we can write the following. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A times the probability of B, because they're independent. Now I can substitute with numbers. So 0.4 plus 0.3 minus 0.4 times 0.3 times. Okay, so this is together 0.7, and 0.4 times 0.3 will be 12, and there is one decimal place here and one decimal place here. Together they become two decimal places. So we'll count two decimal places, put a point, and that's 0.12. So minus 0.12. So 0.7 minus 0.12. Now in subtraction and in addition, if you want to subtract decimals or add decimals, you can't subtract with different decimal places. This is two decimal places, this is one decimal place. You cannot subtract, you cannot add. What you need to do is add a 0 to the right. So it becomes two decimal places, two decimal places. So now you look at it like 70 minus 12. So what is 70 minus 12? You will get 58. So this is the probability of A union B. Okay? So I hope this one is clear. Let's look at the other parts. So they want the probability of A condition B. Okay, so they are independent, right? I can solve this in two steps actually. We can say because A and B are independent, this is part B, okay, are independent. So therefore, the probability of A condition to B is actually the same as the probability of A. They're independent, so A does not care about B. So it's the same as the probability of A, which is going to be 0.4. And that's it. I don't need to solve further. You can use the formula, which is probability of AB over probability of B, but it really does not matter because you will eventually end up with the same answer. So if they're independent, then A condition B is A. What about B dash condition A? So the same thing, because B dash and A are independent. And by the way, guys, sometimes in the ministry, they write the dash like this on top of the letter. It's the same as B dash. Okay, how do we know that B dash and A are independent? If A and B are independent, then A and B dash are independent, A dash and B are independent, and A dash and B dash are independent. This is what we have seen in the previous slide. So because B dash and A are independent, therefore the probability of B dash with condition to A is the same as the probability of B dash. Do we have it? No, but we can find it. It's 1 minus the probability of B, which is 1 minus 0.3. This is 10. So 10 minus 0.3 is 0.7. And that's it. I hope that this one is clear. Let's do another one. So, given that A and B are two independent events, the probability of A is 1 over 3. The probability of A union B is half. Calculate the probability of B. Okay, this might need a little bit more work than the previous one. Let me show you how. I am actually going to start from the given, from here, from the probability of A union B. I know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of AB. I have the probability of A union B, which is half. I have the probability of A, which is 1 over 3, plus I don't have the probability of B, I'm actually required to find it, minus the probability of AB is also not given, but they are independent. So because A and B are independent, are independent. So therefore, we can say that the probability of AB is equal to the probability of A times the probability of B. So how much is the probability of A? So this is going to be the probability of A times the probability of B. So let's continue here. This is a fraction. I can move it with this fraction. So it is half minus 1 over 3 equals the probability of B minus the probability of A, which is 1 over 3, times the probability of B. Okay, here I need to unify the denominators. Multiply by 3, multiply by 3, multiply by 2, multiply by 2. So the denominator becomes 6. And the numerator is 3 minus 2 equals. In this side, I think the easiest way to do is to get probability of B as a common factor. So if we take it as a common factor, we'll still have 1 because we've taken probability of B out, so we get 1 minus 1 over 3. 1 minus 1 over 3, 1 over 1 times 3 times 3. So what do we get now? So we will get 1 over 6 in the left-hand side equals probability of B times, the denominator is 3. In the numerator, we have 3 minus 1. So 1 over 6 equals the probability of B times 2 over 3. Now to cancel 2 over 3, you can divide both sides by 2 over 3, or you can multiply by the reciprocal, 3 over 2, and also here by 3 over 2. This is going to cancel the 2 over 3, and we will get the probability of B eventually as equal to, we can cancel the 6 with the 3, we get 1 here and 2 here, so we get 1 over 4. So this is the probability of B, and hooray. It's a little bit some hard work, but it's equations. You just substitute the numbers and try to solve the equation to find the probability of B. Think of the probability of B as x, so find the value of x. Let's solve the second part. The second part says that we want to find the probability of B dash with condition to A. So again here, guys, if A and B are independent, means that B dash and A are also independent. So because B dash and A are independent, so therefore the probability of B dash with condition to A is equal to the probability of B dash alone, no need to A, which is 1 minus the probability of B. And we have just found the probability of B in the previous part, which was 1 over 4. So 1 minus 1 over 4 over 1 times 4 times 4. So we get 4 in the denominator, 4 minus 1 in the numerator, which is 3 over 4. So this is going to be the answer to part B. Okay? So with this example, I'm going to end this lesson. And if you need to do some extra exercises, you can practice the exercises on pages from 176 to 179. Look at the questions 1, 3, 5, 9, 13, 17, 19, 20. You'll have some questions on independent events and some other questions on conditional probability. I hope that this lesson is clear. And with this lesson, I'm going to end the lessons of probabilities. And I'm going to start with the lessons of the conic sections. Now, there is one more lesson of probabilities, but I'm not really actually sure about it. It's usually cancelled every year, and I think it's going to be cancelled this year for sure. If it's not cancelled, I'm going to give it to you by the beginning of next week, inshallah. But tomorrow, I'm going to start with you on chapter 4, which is going to be about conic sections. If you have any questions, please feel free to ask me via WhatsApp, via Facebook. The most important thing is that you ask. Practice and ask. And I wish you all the best. And until I see you, I hope that you all stay safe and sound. And peace.